All right, hello and welcome to the final week of classes. You made it. All that we're going to do in these last two lectures is review for the final, so sit back and let's go for it. So there's going to be two major parts to the final, and one of them, maybe the first one, depending on the order that I give, is going to be a short essay. So in that essay, you're going to maybe argue something, or at the very least, convince me that you understand something related to the things that we've learned about. So let's give a quick review of some of those things that we can use to maybe analyze an argument, or just like frame an idea and help us to think about it. So we'll talk about ethics and then fallacies, and then that'll be that for the non-programming side of things. So the first thing that I want to talk about is Kantianism. So that was one of the very first ethical theories that we learned, and Kantianism was invented back in the day by a man with the same last name, Immanuel Kant, and it's an ethical theory. So this is about ethics, which is the study of, well, what is right and what is good. What should you do in a given situation? How do you understand? How do you break down what you need to do, and maybe argue in favor or against doing something? So what Kant thought. He framed his ideas in a few different ways, and the way that a lot of people like to explain it is this first way. It's Kant thought that you should always act in a way, that you'd want everyone else to always act. So there's two key things. So always is key, and then everyone else is also key. So in summary, you don't get any special exceptions for yourself. If Kant's viewpoint on a certain topic was, okay, you can never do this, and you try and think of some bizarre scenario in which it might make sense to actually do that thing, Kant's still going to say no. No, you always have to act this way. You get no exceptions. Does not matter. Okay, so that's the first way that he framed his ideas. And then another way that he talked about what he thought. The other maxim of Kant was, don't treat people as a means to an end. And so if you want something, you can't just use somebody to get it. You have to treat them like a human being, and hopefully you can come to some agreement, perhaps. So those are the two main things that Kant believed, and we can use that to break down some kind of topic, some kind of theory, or anything that you might want to do. So let's give an example first with lying. So these are the two examples that I gave back in the day as well. So let's revisit them. So the first example is lying. Kant was very specific about lying. He thought that was a horrible idea. You should never do this, says Kant. So he even wrote that. So he was a firm believer in the fact that you should never lie, because it would be really nice, like you would want everyone else to always tell you the truth, so you should never lie to anyone else. Okay, that's the idea, and that's how we can argue it. So that's pretty obvious from Kant's point of view. But Kantianism, well, it's an ethical theory, and like all theories, like all things, it has some cases where it breaks down. And so would you not lie to a murderer who comes to your house and asks you, hey, where is your friend? I want to kill him. I think most people would want to lie in this situation. But Kant says no. Kant would tell the truth. Kant would say, oh yes, he's in his bedroom, and that's the end of that. So that's one place that Kantianism breaks down. Another famous place to talk about, another famous argument or counter-argument to Kantianism is stealing. So stealing is something you would never want anyone to do to you, so obviously Kant would be against it. And also, it's kind of treating people as a means to an end. Like, they have food, I'm going to take that from them. I don't care if they're going to go hungry. It's mine now. So, again, stealing is something that Kant did not like. Boop. So, same kind of story there. And again, there are some counter arguments. Like, okay, what if it was to feed your family? Like, there's no other way for you to get food. You have to steal. And Kant would say, well, we're just going to go hungry. There's nothing we can do. And hopefully he would try and, like, get into some kind of pact, like work with somebody to get food, and hopefully, like, give them something in return. That would be ideal for Kant. But again, you would want to, like, if you had no other options, like nobody's helping you out for no good reason. What happened to that? Oh, I'm ruining everything by typing more. Again, Kant would be against this. That's just how he rolls. Whee. Okay, now it looks right again. And so even though there are some cases where maybe you'd want to steal, in Kant's ethical viewpoint, that is a horrible, horrible idea. And so we can use Kantianism to talk about other things, and you can go back to the lectures to see what we talked about in the realm of computer science and technology. But that is Kant in a nutshell, and you can use that to look at different viewpoints. So the second main topic that we talked about, the other ethical theory that is well in use today, is called utilitarianism. And, well, that one's all about utility, right? You want to maximize utility / happiness for every action. So every action that you might take, figure out, okay, if I do it, will it provide more utility than not doing it, right? So it always comes back to the consequences of an action. And when I say maximize, it has to do with maximizing for everyone. Not just you. So maybe doing something maximizes your utility, but like ruins the utility of 50 other people. Again, utilitarianism would be very not about that. And John Stuart Mill was the proponent of utilitarianism, one of them. And a good example of utilitarianism is murder, murdering like one person to save 50, like we did at the beginning of the class. So from a utilitarian point of view, this is obvious. Obviously, we're going to save the 50 people in most cases. The one case that I can think of where maybe it's better to let the 50 people die and not murder the one is maybe if this one person is like very powerful and can potentially, like, by living, save more than 50 people, something like that. Maybe it's like a special doctor that can do one thing that no other doctor can do and save people that way. Who knows? So this is all a thought experiment, but you can use utilitarianism to talk about, like, oh, should we do things? Should we censor the internet? Things like that. You can use Kantianism to talk about that as well. So just keep these in the back of your mind. They may come in handy on the essay on the final. So think about that. And then the last thing that I want to talk about that's non-programming stuff is fallacies. So a fallacy, it's just when you are like arguing something or you're reasoning about something. Maybe you're not making an argument, but you're just trying to reason through something in your mind. And you make an error. Okay, you make some kind of logical error while you're reasoning or while you're arguing, and that just makes your argument or your reasoning null and void. So automatically, it is not true whatever you just thought or argued if you accidentally use a fallacy. So Thanksgiving will have happened by the time you watch this video. And fallacies are that stereotypical thing that comes up at the dinner table where everybody's arguing with each other. And at least one of the people will probably include a fallacy, so that is fun to think about. One main thing, one very key thing about fallacies is that every fallacy has a name. So in this class, it's not just fallacy means you made an error. No, it's you made an error and it's this particular kind of error. Okay? So that's what a fallacy is. And we learned a bunch of different kinds. And I found some memes on the internet, and we'll use those to recall 3 different fallacy types. Okay, so let's look at the first one. This one is false dilemma, and it's a meme, and I'm sorry that it was made improperly, but this is the... Hopefully you can see that. Me who's getting $150,000. So this one's the false dilemma, or the false dichotomy fallacy, this meme right here, is because it's kind of, if you read between the lines, it's saying like, okay, either you get $50,000 and somebody else gets more than you, or you get no money at all. That's essentially what it's implying. Like, it's some kind of hypothetical scenario, and obviously maybe you don't want that person that you hate to get $100,000. But this person saw that there is a third option. So it's not a dichotomy. There's more than meets the eye here, and this man who hates himself apparently is going to get $150,000 out of the deal. So obviously he'll press the button. So false dilemma is also called false dichotomy. It's when you give the appearance that there are fewer options than there really are. Okay? So that is a false dilemma fallacy. Then straw man is when you build up an argument that isn't the same as the original problem, and it just knocks over in the wind because it's straw man. So let me give you this example. So apparently in Austria, they banned all gatherings of more than 5 people at some point in time because of the coronavirus. And so this meme is like, okay, families of 6, we have to kill one of you now, or you have to leave us, something like that. So it's implying that, okay, yeah, this ban is horrible, obviously, because families can't even be together now if they're large. And that's a straw man, because if you go and read the fine print of this, most likely it's talking about gatherings outside of your familiar unit, things like that. And obviously, if you are a family, you live in a house together, you can totally all hang out. That's not a problem. So it's building up an argument to something that wasn't even the problem. Okay, that's what a straw man is. And then good old tu quoque is Latin for you too. And it's just when somebody else makes a mistake or does something silly, and you argue that, yeah, that was wrong, but then they come right back at you for your crimes that you have made. So it's the quintessential know you on the internet. So those are 3 fallacies that I wanted to bring back to your mind. Obviously, there are plenty more than that. Go back to the slides, look at the Wikipedia page. They're fun to think about. Just the one thing that I want to ingrain in your mind is when you make a fallacy, you automatically lose the argument. You are automatically wrong. And then every fallacy, if we're going to be formal, like we are in this class, it has a name. Okay? So those are our fallacies. And that is all of the non-programming stuff that I wanted to review. Just prepare to write an essay and to convince me that you are correct about something. Okay. Moving on now to the Python review. So we're going to go over practically everything that we talked about. I have plenty of examples, and that will be the rest of the lectures in this class. So we'll try and get through this. So first of all, I have made you a very beautiful cheat sheet. I worked very hard on it, and here it is. So this is what I'll be giving you. I'll post it somewhere on Canvas that you will be able to find. But I've made pages for conditionals, which are your if, and then your else's and elif statements, how they execute. I've made a page for loops, while loops and for loops, how they generally execute. There's more to a for loop than meets the eye. It's not just a list that it can iterate through, but we'll just pretend that that is the case, because that's how I taught it in this class. feel free to ask me about it in office hours if you want to go down the rabbit hole. And then also functions. I've made a nice page with just helping you recall the syntax and what's going on, like how do these parameters line up with these arguments, and like how does body get executed when the function is called, things like that. Okay, so that is my beautiful cheat sheet that I made for you. We'll come back to this. And let's just get started now with the review. So there are a bunch of different types in Python. So each type can hold different things, and you can think of them like a cloud. So the int cloud can hold whole numbers, like 42, negative 42, 0, 1024, large numbers, small numbers, 0, but they're all whole. There are no decimal places. All whole numbers for ints. And you can use, if I just make a new file, you can use the type operator in Python to print out the type of a given variable or value. So let's, I don't know, what do I want to talk about here? So, I don't know. Let's just start out calling it with review 1 or something like that. Review part 1. So ints, 42, whatever. The type of all of those, 42, negative 1, if we print that out, that is going to be an int. Yay, so it's an int, and you can do this on the REPL too. It's like, okay, what is the type of 42 int? What is the type of 42.0? Well, that's going to be a float now, because we included a decimal place. It's completely different. Okay. So that is very basic Python stuff. You can use the type to get the type of something. Okay? You can actually compare it later if you'd like. And then obviously remember your print statement, which prints something, and then a new line at the end of that, and then type gets the type of something. And these are comments. A number sign is code that does not get executed. It is just for you to see. Okay, so that's int. Int is whole numbers. I hate how it automatically capitalizes this because it's now incorrect when we do that. So float is numbers with decimal points. And so for float, you can start doing things like 3.14, negative 42.87, things like that. And that's what float can do for you. And for all these numerical types, you can also like do operations on them. Of course, you can be like, all right, print 42 squared, print, I don't know, 2 times pi times the radius, which was apparently 5 or something, and then plus 7 for no good reason. All of this works, and it does exactly what you would expect. Okay. And so that is int and float, our numerical types in Python. Bool is for Boolean values. And in Python, you only have 2. It's true and false. So something can be true, something can be false, and the type of that is Boolean, or bool. We can print out that. And it was class bool. That's what it was. Okay, true and false is very useful. You can combine these, of course. With and, or, and not. Remember all of those. You can totally do that. So like not, not true. Well, let me type. Not true is false, and vice versa. True or false is still true, but true and false is false because both need to be true if you want to use and make it true. Stir is for string. And I don't know why they call it that. Think of it like a friendship bracelet where you're putting a bunch of different beads with characters on it. So it's like a string of characters. it holds words. So whatever word you want to think of, you can put between double or single quotes, and that makes a string. Boop. I guess we can go to the file. Print type. Hi, Mom. It's a stir. And you can add strings as well. You can be like, hi, plus space, plus mom. That totally works. Maybe I'll include that as an example. That's quite nice. String of characters you can combine with plus, and also times. There are more. You can get the length with len. Lists are essentially, you can think of them as strings, very similar to strings. They can just hold any value. So it's like a gift. It's all wrapped up in a list. You have, you could be like L, or I don't want to get into variables yet. We'll get into them right after this. You know what, let's just start. Let's just start talking about variables, why not? You can say L equals, and that's a variable L now, 1, 2, 3, 4. And you can start getting everything. You can add it to itself even, I don't know, and then it becomes 2, 4, 6, 8, which is fun. You can get the length. You can add lists. These all this stuff works. So L equals 2, 4, 6, 8. And you can add lists to lists. And now it's 1, 2, 3, 4, 2, 4, 6, 8. That's fun. You can get the length of lists. It's 4, things like that. And then also variables. L is a variable. It can hold whatever you want. In this case, it's a list. Which makes sense. We called it L. Okay, so that is all a bunch of things. So we have types, operations on those types, variables. Let's talk about input very quickly. So input is a function that optionally takes the prompt that you want to give the user as they type. And every time you use input, you get a string back. Excuse me. And, well, that might not work in the case of, in several cases. Like maybe you wanted the user to type in a number, but you got back a string. So let's talk about that. So input gives back the answer that the user gave. Okay? Or the user's response, let's say. And it's always a string. So if I say print answer, and I can say print answer's type, this is now going to be interesting. So please type a number 42, but it's a stir. It's string 42. There's a big, big difference between the string 42 and the number 42, okay? If I try and add the string 42, like if I try to multiply the string 42 by 2, I get 4242, the string. Okay? So just remember that. That's not as fun as you might expect. Oh, one other thing that I wanted to talk about with lists before we go any farther is indices. if you want to pick something out of a list, you can use these indices. So like L, the list in Python, holds those 4 things, 2, 4, 6, 8, in order. This one. The index of the 2 is 0, the index of the 4 is 1, then 2, then 3. Okay, so if I want to get the 2 out, I say L of 0. If I want to print just that. Okay. I can give commas between things and print, and it will just put a space and then print the next thing. So like L of 0 is 2, because we went inside of L at index 0 and got out the 2. Okay, so that's quite nice. What if you wanted the 42 and you want to like multiply it by 2? So like print answer times 2. That's not what we wanted, as I showed you. If I type 42 again, that's not what we wanted. What you do want is to convert that. So in order to use answer as a number, you need to convert between types. From a string to an int, in our case. If these are typed a decimal number, you'll convert it to a float, of course. So you can say, you need to say int answer, and that'll give you back the int. And we can just set that right back to answer if we wanted to. You can say that, or you can say, if it helps you think about it, make a new variable called like answer int form, or something like that. And now you can print answer int times 2, and that is what we wanted. So if I type 42, 42 versus 84, which is what we wanted. We have to convert it to an int. Now answer int holds the number 42. And we can go and print that. Okay? Quite nice. Just remember to convert those types. So, there are more operations than I talked about. Remember how to compare things. Remember your double equals, not equals, your less than or equal to, etc. Those all return true or false. And based on those, you can control your program. Using things called conditionals, which you know as if, elif, and else. Okay? So, I have 2 examples for you. The first one is you must be this tall to write. So we're going to get input from the user and be like, okay, how tall are you? And then we'll check that they are, I don't know, 48 inches or something. How about that? So that's what we'll do. And so we'll get the input from the user. We'll be like get input. Then we'll check, hey, was the input greater than, or the int form of the input, of course, was that greater than or equal to 48? Whatever I said. And based on this, based on the result of this, we can do 2 things. We can be like, if it's true, be like, you can ride. If it's false, you can be like, you can't ride. Or you need to like ride with a parent or something, whatever this ride is about. Okay, so let's do this. That's example 1. I'll make a new file. Call it conditionals.py, and let's see here. So we want to get the input from the user. So it'll be like height equals input. What is your height in inches? It'll be like enter your height in inches, maybe. How about that? And so we'll get that, and then we convert it to an int so that we can use it. We can actually do that right in line. Be like, all right, whatever input gives back, pass it straight to the int function to convert it to an integer. So you can do them right after another, one after another. And now height holds the int form, the number of inches. Hopefully the user doesn't type it in decimals. Okay, so now we have it, we can compare it. We can be like, okay, if the input, if the height is greater than or equal to 48, we can say, okay, yes, you can write. If it's not, if that was false, that's what our else case is for. We can say print, you can't write. Okay, so let's run this a couple times. Enter your height in inches, 42, you can't ride, but if I say 48, suddenly I can ride. And then from there onward, I can always keep riding. Okay, so that's the idea of that. And then let's go back to our examples here. You can have an if statement without an else case, and that would just only execute the body if the if condition is true. Otherwise, it would just go straight to whatever's after the if statement. Okay, so that's if statements by themselves, and then we just talked about if else statements, which they take the condition, so the thing that you're checking, they come up to it, and then if that condition is true, it'll run the body of the if statement. Okay, and then it's only one or the other. So after that's done, it'll immediately start executing the rest of the code. But if it's not true, if the condition is false, then we'll go straight to the else body, execute that, as many lines as it is, and then once that's done, we'll go straight to whatever's left, whatever's unindented. So remember to indent all of your stuff. So that everything works as it should, because if this is outside, it's now an improper if statement. It's like, okay, what's the body of the if? Where is that? You can put as much stuff as you want in here. And they'll all get executed. Okay, that's the idea for that. So that's conditionals. Then elif is when you want to give multiple options. Okay, so let me show you just a single if else case, and then we'll go to a fancier one. So you can have as many elifs as you want in between an if and an else. And the way that you want to think about it is, okay, it's try all the options. So elif will try the other option if the first one fails. So it's always one body. You're only ever going to execute one of these bodies, but it depends on these conditions which one. So if the first condition is true, you're going to go straight to the if statement's body. Execute that, then you're immediately done with everything and go to the after. Okay? Otherwise, if that's false, you're going to now try this one. Okay, so if it's false, we'll try this one. Try condition 2. If that's true, then we'll do its body. Oops. We'll do its body, and then we're done. Otherwise, if both of them are false, we'll go to the else case then, and then we're done. Okay, so that's if else, and let's use this to calculate grades. And the idea is we can check, okay, what was the grade? Get input again. And we can say, okay, was the input greater than or equal to 90? If that was true, then it's an A. If that's false, then we need to try something else. Was it, okay, if it wasn't greater than or equal to 90, what if it's, then we know it's less than 90. What if it's greater than or equal to 80? If that's true, then it's a B. Otherwise, we should start checking if input is greater than or equal to 70 to check if it's a C. So that's that case. Then go down the other branch if it's false and try to see if it's a D in that case. So you can use as many elifs as you want. They all the conditions are checked in order, and the first body is executed that works. Okay. So let's try this now. Let's be like, okay, after this, let's say we're getting the grade. So enter the grade, and this can be a float value. So maybe your grade is like 87.9 or something. Oops. So we'll say grade equals input, the float version of the input what is your grade? And then we'll give them a space to type it in. And so now we'll say, okay, if the grade, which we've already converted to a floating point number, so we can use numerical operations on it, if the grade is greater than or equal to 90, then we know it's an A. We'll print A. And then, well, if that's not true, then let's try the next option. Elif, grade is greater than or equal to 80. How about that one? And that's the B case. So we can keep trying these. Then we have the C, the D, and then the F case. C, D, E, D, and then this last one will be else. So if it's greater than or equal to 80, we'll do B if it's greater than or equal to 70, but not, like these other ones failed. So we know if we got here, we're going to say C. That grade is less than 90, and so it wasn't true, so it must have been less than, not greater than or equal to. And we know also that this one didn't hit, so it was less than 80 as well. So whatever the grade is, actually, if we get into the body, if we get here, we also know that grade is greater than or equal to 70. So that means this one is kind of overshadowed by this one. So we know that the grade is somewhere between 70 inclusive and 80 exclusive. So it's somewhere between 70 and 79.9999. Okay? That's the idea. So I hope you see that if we got here, it must be a C for this reason. Okay? All right. If it's greater than or equal to 60, we'll print a D, and then else. If we get here, none of the cases were true. And in that case, we know because of the last one, the grade is less than 60, so it's an F. Okay. So you can try this out as much as you want. I don't know, I have to do the height first. What's your grade? I don't know. 42, go straight to the F case. If I rerun it, what's your grade? I don't know, 75, we get a C. And then if we got extra credit, our grade is like 110. No, sorry, 110, it's an A. Okay? Anything greater than or equal to 90 is an A. Okay, hopefully that's making some sense. That's our if, else cases, and that lets us try a bunch of options and take the first one that is successful. Okay, while is a loop, so it's all about revisiting code. Okay, we want to revisit some code, and I guess the quintessential example is to like go between some numbers, like between 1 and 10, and maybe print them all out. So the idea is we'll make a variable called I, start it at like 1 or something. I is a common value for this. It's called, because what we're doing is iterating between 1 and 10, so I is for iteration. So you start I at 1, you'll be like, okay, is I still less than or equal to 10? If that's the case, then print it, and then increment I. Then we'll go back, try that again. That's where the loop comes in play. Keep on looping that way. And then finally, if that's ever false, then we're done. Okay, so that's the idea for printing all the numbers from 1 to 10. So let's convert this to a while loop and go from there. This is a loops.py. So we'll print the numbers from 1 to 10. So we'll start our I at 1. And we want I to keep going as long as it's less than or equal to 10. So we want I to go from 1 to 2 to 3 to ... to 10. Okay? So while I is less than or equal to 10, in that order, we're going to print I, and then increment I, so that our loop eventually stops. So I equals I plus 1. All right, so I is going to go between 1, then it's going to be 2, then it's going to come back, print 2, going to be 3 now. Okay, in that order, it's going to print from 1 to 10. I hope that's not too bad. So that is how this executes. And if we go to our handy dandy cheat sheet, a while loop is all about a condition again. So it's just going to keep on executing the body of that loop as long as the condition is still true. And eventually, the goal is eventually that the condition should become false, or you otherwise break out of the loop. Okay? If you ever wanted to stop early, you can say break. Okay? If you ever had a reason to, like, okay, maybe this was while true or something. No, let's keep this and let's copy it over here again. Alternatively, I starts as 1, and we can make like a forever loop if we wanted to, and then stop the loop here in the body. And break stops the loop. So this will do the same thing, because the second that I becomes 11, it'll stop the loop, because this will become true. And hopefully you see the game that I'm playing here. These will both work. They'll both print from 1 to 10, but obviously this one makes a whole lot more sense. But you can do what you want. There are a million, infinite different ways to write a program. Okay, the next example that I want to give is summing all the numbers that a user types in until the user types -1. So the idea is the user will type, I don't know, 42, then 43, then 44, then 1, then 2, then 3. And the second the user types -1, we don't count the -1, and we just sum all these things. Okay, so that's the idea. That's what we want to do. So we want to keep getting numbers, keep getting input, until the user types -1. So here's what we can do. We can store the user's input in a variable, and we can say, type the next number, -1 to quit. And we're going to store that in some kind of variable. Maybe we'll call it next num or something. Okay, so we're going to get that, and then as long as, oh, sorry, I didn't close the input, that's why it was unhappy with me. While the input in int form, because the user's going to type numbers, is, actually we'll just convert it here, why not? Let's make it an int. While next num is not equal to -1, do this, okay? So the second next num is equal to -1, this loop body won't execute. And so it'll go here, it'll go to the outside, and after the user types -1, we want to print out the sum. Okay, so let's save the sum as well. The sum starts at 0, because the sum of any numbers, the sum of no numbers is 0, and we'll just add to that. Okay, so we'll then say sum equals sum plus next num. Okay, and we'll just keep on doing this, keep on adding to the sum, and then re-asking the user for the next number. And I hope that will make sense as to why that works. Okay, so then the second we ask again, maybe the user typed -num this time, or -1 this time, so next num is equal to -1, so the loop will stop, we'll plop out of it, we'll plop out of that loop down here, and then we'll do what we wanted to do after it was done. So we'll say, print out that sum. Or we can be fancier about it. Like the sum was, and then the sum. How about that? Okay, so that should do it. Are you ready? Type the next number. Well, if I type immediately -1, the sum was 0. That's no fun. If I do this, I can say, okay, 1, the next number is 2. It'll keep on asking me numbers. It keeps on doing this body, which includes asking for numbers and adding to the sum. 3, 4, and now -1, I'm done. I want to add from 1 to 4. Ah, the sum of that was 10. Cool, huh? I guess I didn't need this space. Okay, so that's while loops in a nutshell. Hopefully this is all coming back to you, or it's just becoming stronger in your mind now. Please do come to office hours. I'll be having some this final week of classes, of course. Please take advantage of them if anything is confusing. So the last thing that I want to talk about today, maybe we won't have enough time to get through all of it, is for loops. All right, so a for loop is just another kind of loop, but it iterates through something, okay? For loops iterate through things. Usually in this class I've talked about lists. So you can just think that everything that a for loop iterates through is a list. So range, for example, is secretly a list, or something that is kind of like a list. It's a list-like thing that holds 0, 1, ... to 49, not including the 50. I guess that's what range does. Let me prove that to you. Range 50 convert that to a list so that we can see it. And oh man, is it 0 through 49? So that's what range does for you. It gives you something to iterate through. That is a list that you can think of. You can think of it as a list, and it will go through all those things. So for loops, it's always for and then in, for some variable in something else. And it's just going to keep on getting the next element out of that list and setting the var equal to that and executing the body. Okay? Just keeping on looping like that. So let's get a bunch of stuff from the user and then find the minimum thing that the user enters. So here's how we'll do it. We'll say, we'll get a number. Dun, dun, dun. So when the user's done, let's say, they'll type -1, then we'll have a list equals like 1, 2, 3. And the idea is we want to iterate through all elements of that list. So like for E in L, you can be like, okay, was it smaller than the last one? So update the minimum. Using E, potentially, okay? So like some min, and we can start the min at the first thing. So pretend that the min is the first thing, and then see if we ever need to change it. And in our case, it is the first thing. Okay? So that's the idea. We're going to loop through the list of things that the user entered and continually update the minimum. So pretend, make a guess that the first element is the minimum, and then loop through the list, updating our guess. Once we're done getting through the entire list, the minimum will be stored in the minimum variable. So this might make not a lot of sense right now, but don't worry, I'm about to show you what to do. And then that'll be it. So let me copy some of the stuff that we used already. We can be like, get our numbers. Boop. And instead of adding to sums, we could say, this can be for loops, maybe. For loops.py. This is just the first one, though. So instead of getting numbers, let's get numbers and then add them to a list. So let's start our list empty, and then add to it each time. Because you can add to lists. You can say, like I did once upon a time, you can say your existing list plus a new list, another element. Okay, then it adds it. Adds a new element to the end of that list. All right, so we're going to get a number from the user, and we're going to keep track of our list. So add the number to the list in our case. So it's L equals L plus the list containing next node. So increase the list L by one element. So add it to the end, then we'll ask for the next number. So now we have the list. Now L is filled with stuff. Let's find the minimum. And so what you can do is you can say, well, for x in L, and then we'll loop through. But before that, we make a guess. Guess that the first element is the minimum. We'll say guess equals L of 0. Okay? Now we can say for x in L. I guess we'll go through the guess already, but that's okay. We'll visit it once more. It's not going to matter. Then we'll say update our guess. So if necessary means if the thing that we're seeing from the list is smaller than our guess so far, then it's the new minimum. And I'll give you an example of this to drive it home. We'll say guess equals x. And then once we're done, we can print it out. We can print guess, or the min was guess, sorry. All right, so I'm going to prove to you that this works. Let me show it to you. So it doesn't matter the list that the user types. So maybe L is 42, 41, 47, so the minimum's right here. Or maybe L is 1, 2, 3, in which case the minimum is right here. In either case, we're going to make our guess, being the first element. So guess is 42. And we're going to visit every element of the list. 1, 2, 3. So, is 42 smaller than 42? No. Is 41 smaller than 42? Yes. Replace our guess. Is 47 smaller than 41? No. We're done. And then the guess is the minimum. Isn't that cool? So again, we make our guess. Okay, the first element is the minimum. Compare it again. It's not smaller. It's not smaller. It's not smaller. So, at the very end of the day, we've compared against every element. So, and replacing it if it's smaller, that means our minimum is stored in the guess variable. Okay, hopefully that's not too bad. Let me prove it to you that it works, and then that'll be that. So get stuff from the user, 42, 41, 47, -1 to stop. So the min was 41, very nice. And then let's do it one more time with 1, 2, 3. Yeah. 1, 2, 3. -1, and the minimum was 1. Very nice. So that is the first example. I'll come back with the next one in the next lecture. So I'll see you then.